section 412, which is titled Factoring with Area Models, and your Chromebook will be useful. So if you want to pull that out in a minute, you can. And we're going to be answering the question, is there a faster method? So we're going to be completing pages 4 and 5, but we're going to read the bottom of page 5 first. So flip over to page 5, down at the bottom. And that is our math notes box. In the math notes box, here's what we have. And it tells us about the diagonals of the area model. So yesterday, we looked at a problem about Casey's pattern. So why does Casey's pattern from problem 4.4 work? That is, why does the product of the terms in one diagonal of a 2x2 area model always equal the product of the terms in the other diagonal? So how many of you figured out the pattern yesterday? A couple people? So the pattern's basically this diagonal, if you multiply this times this, is going to be equal to this diagonal, this times this. I think it was 30x squared and 30x squared. So you'll get the same thing if you multiply diagonally this way and you multiply diagonally this way. I had some students even calling it the cross product because we do that a lot with our fractions, right? Okay, so it says examine the area model at right for a plus b times the binomial c plus d. Notice that each of the resulting diagonals has a product of a, b, c, d. Thus, the products of the terms in the diagonal are equal. All right, so flip back over to page 4. Up at the top, we're going to be looking at question 412. So for question 412, it says, examine the area model shown at right. Hi. Just go ahead and sit right there for now. I'll get you some stuff in a minute. Examine the area model shown at right. Review what you learned in lesson 411 by writing the area of the rectangle at right as a sum of the product. Okay? So this area model somehow avoided the hole punch, but it's there. Okay, so to get 10x squared, we have 5x and 2x. To get negative 35x, we have 5x and negative 7. To get 14, we multiply negative 2 times negative 7. And to get negative 4x, we multiply negative 2 and positive 2x. Let's test and see if the method that we learned yesterday is correct. So if we multiply diagonally this way, we have a negative times a negative, which would make it positive. And then we have the coefficients of 35 and 4. What would that be? 140. And then we have x times x would be x squared. So 140x squared. Now let's check this diagonal. The coefficients of 10 and 14, if you multiply that, would be 140. And then we have an x squared here. So 140x squared this way and 140x squared this way. All right? We want to write this as a sum. So the sum is on the right here, 10x squared minus 39x plus 14. And as a product, the product would be 5x minus 2 times the binomial 2x minus 7. Okay. Any questions on problem number 12? All right, part B for problem number 12 says, does this area model fit Casey's pattern for the diagonals? State the pattern and justify your answer. Okay, so for the diagonals, we're going to do what we just did. Multiply the negative 35x times the negative 4x, which gets us 140x squared. And this diagonal, multiply the 10x squared times the 14. We also get 140x squared. And so we say, yes, we have equal diagonals when we find their product. So this is just one extra method that will help us solve these faster. Okay? Question number 13 says, a polynomial in the form of ax squared plus bx plus c, where a does not equal 0, is called a quadratic expression in standard form. To develop a method for factoring quadratic expressions without using algebra tiles, you will first model how to factor with algebra tiles and then look for connections within an area model. Okay? So for part A, you can use algebra tiles to factor the 2x squared plus 5x plus 3. That is, use the tiles to build a rectangle, then write its area as a product. And they want you to use the tool at question 413A, the student E tool. Okay? So we're all going to go there now. Okay? Let me get you guys